Students, now we are discussing digital electronics questions in Telangana Genco electronics question paper. The question number is from master question paper, question number is 31. Which of the following logical gate is implemented using the circuit shown below, where V1 and V2 are inputs with 0 volts as a digital 0 and 5 volts as a digital 1, then V out. Here he explained logic family question. This question is related to logic families, and in logic families we discussed here DTL, RTL, TTL, like this, so many logic families we discussed there. This question is related to RTL. RTL means what? Resistor, transistor, logic family. So if you see NAND gate, NOR gate in RTL, this is a standard bit, this is equivalent to NOR gate. This is equal to NOR gate. We know that in a NOR gate, this is NOR gate symbol, and inputs are A and B, output is Y, where Y equal to A plus B whole bar. So I am writing truth table of NOR gate here. A, B inputs, Y is output, 4 combinations 0 0 0 1 1 0 1 1. I am writing 0 plus 0 0 bar 1, 0 plus 1 1 bar 0, 1 plus 0 1 1 bar 0, and 1 plus 1 1 bar 0. Same thing now I want to explain in terms of voltages. He mentioned here 0 volts means 0, 5 volts means 1. So I am writing transistor T1, transistor T2, writing I am 0 volts, 0 volts. What happens when it is 0 volts, when it is 5 volts, what happens when it is 5 volts, when it is 0 volts, what happens when both are 5 volts, what happens. Here you remember one point, when we are giving voltage to transistor, if it is ideal transistor, it acts as short circuit, and when there is no input voltage, it acts as an open circuit. Open means we are considering as a here open. See here both are off. When both are off, maximum voltage will be considered, that is 5 volts. If any one of the transistor is on, what is the output voltage? 0 volts. Hence this electrical truth table is similar to this zeros and ones truth table. Hence this is equal to what type of gate? NOR gate. Students, next question we are discussing, that is question number 32. Is given one Boolean expression y equals to a into a plus b plus c, a into a plus b plus c. Then is asking convert into standard POS form. Yes, this is POS form. So here product of sums, individual term is a sum term, all these terms are producted, that's why it is known as product of sums. So how I am simplifying? Convert into standard. See here, we know one property a plus bc, that equal to a plus b into a plus c. That is very useful here. A plus bc equal to what? A plus b into a plus c. Now I am to convert to standard POS. All inputs will be included here. So I am writing a plus bb bar plus cc bar, a plus bb bar plus cc bar into a plus b plus c, a plus b plus c. According to a plus b plus property, I am writing C, a plus bb bar, I am writing a plus b plus cc bar into a plus b bar plus cc bar into a plus b plus c. Now again I am considering this is one term. So a plus b one term I am considering. So a plus b as it is. Now cc bar I am writing a plus b plus c into a plus b plus c bar into, again I am writing a plus b bar plus c into A plus B bar plus C bar into A plus B plus C. A plus B plus C. So, the correct answer is here option 4 is the correct answer, students. Next question we are discussing here. Question number 33 from master question paper. This question is related to encoders, decoders, and this is a question related to combinational circuit. See here, which of the following is used to reduce the number of data lines required for transmission of occurrence of events? Yes, the answer is encoder. That's why I write here encoder, but the topic is related what? Combinational circuit. Combinational circuit. This is the related topic. See, if you see encoder, the main function of encoder, is, it is a digital circuit. It is a digital circuit which is used to convert, parallel data into serial data. That's why input side more number of inputs, 2 power n inputs, output side less number of outputs, n outputs. That's why we are writing 2 power n divided by n. The size of the encoder is 2 power n by n. So, here the main function of encoder is to reduce the number of data lines. See here, inputs are how many? 2 power n inputs, and how many outputs? N outputs only. 2 power n greater than n. Hence, to reduce the number of transmission lines or data lines for transmission, which combinational circuit is used? That answer is encoder. Option 1 is the correct answer. Next question we are discussing, that is question number 34. This is also related to combinational circuit. See, previous question related to combinational circuit. This is also related to combinational circuits. See, the question is, how can a decoder can be converted into demultiplexer? Students, the main difference between multiplexer, demultiplexer and encoder, decoder. Multiplexers, demultiplexers are controlled by selectors, but whereas encoders, decoders are controlled by enable pins. Now I am explaining the same topic, the same concept in decoder and demultiplexer. See here, a demultiplexer consists n selectors. How many selectors? N selectors. And how many inputs? Only one input, but there are 2 power n outputs. How many inputs? Only one input. Then the size of the demultiplexer is 1 by 2 power n. This is the demux definition. Demultiplexer, n selectors, one input and 2 power n outputs. That is about demultiplexer. Now compared to decoder, what is decoder means? A decoder consists n inputs and 2 power n outputs, This is about decoder. And what is the size of this decoder? N by 2 power n. But here this input, like in decoder we are connecting one pin. What is the pin name? Enable pin. Enable is always active high. So how can a decoder can be converted into demultiplexer? Yes, the correct answer is with enable input. A decoder can be converted into demultiplexer. Option 1 is the correct answer. Students, next question. This question is related to sequential circuits. And the question is related to flip-flops. For a JK flip-flop, its J input is tied to its own Q bar output and the K input is connected to its own Q output. If the flip-flop is fed with a clock of frequency 1 megahertz, then its output frequency will be, yes, we know that a JK flip-flop, consists of two inputs J, K, two inputs, two outputs Q bar. Now what he mentioned, J input is tied to its own Q bar output and K input is connected to its own Q output. In such arrangement, this flip-flop acts as a T flip-flop. The main application of T flip-flop is a frequency divider. If input is given, how many? Input is given as 1 megahertz. Then output will be 1 into 10 power 6 divided by 2, that equals to, what is the answer? 0.5 megahertz. So answer is 0.5 megahertz. So option 3 is the correct answer. Students, next question here we are discussing question number 36. This is also related to sequential circuit. See here, how can a D flip-flop converted into a T flip-flop? Here is given D equal to TQ bar, D equal to TQ, D equal to T XR Q, D equal to T XR Q, means if you know two truth tables of D flip-flop and T flip-flop. See here, first I am writing D flip-flop, D input, Qn past output, Qn plus 1 present output. In D flip-flop, when input is 0, whether the past output is 0 or 1, what is the output? 0 only. And when D equal to 1, past output may be 0 or 1, output is 1 only. So whatever input, output is also same. That is about D flip-flop. Coming to T flip-flop, T, Qn plus 1. See here, when T equal to 0, whether the past output is 0 or 1, when T equal to 0, past output 0 or 1, present output is same as past output. I am writing here 0, 1 only. And here when T equal to 1, whether the past output 0 or 1, the output will be toggle. That means 0 means 1, 1 means 0. This is the truth table of T flip-flop. Now is asking D equation in terms of T. So this is a truth table of T. By using outputs, I am writing D here. See here, I am writing here T. Now I am writing D here. Now observe D flip-flop truth table here. Observe here. When Qn plus 1 0 0, yes, when D equal to 0. When it is 1 1, yes, when D equal to 1. When it is 0 1, yes, when D equal to 1. And when it is 0, when D flip-flop 1 0, yes, 0. So I am consider D equal to 1 in two cases. From this, T bar Qn plus T Qn bar, that is XOR gate. So I am writing T XOR Qn, D equals to what is the answer? T XOR Qn. Hence option 4 is the correct answer. Students, next question we are discussing here. This is a counter related question, counter topic. A basic question is asked here, simple question. N-bit binary counter consists, to design n-bit binary counter, how many flip-flops we need? N flip-flops. How many flip-flops we need? N flip-flop. And this flip counter is used to count from 0 to answer 2 power n minus 1. 2 power n minus 1. Hence n comma 2 power n minus 1 means that counter is need, suppose for example 2-bit counter. 2-bit counter need how many flip-flops, T flip-flops? 2 flip-flops. This 2-bit counter is used to count 0, 0, 0, 1, 1, 0, 1, 1. Means totally how many? 0, 2. 0, 0 means 0, 0, 1 means 1, 1, 0 means 2, 1, 1 means 3. So, from this formula 2 power n minus 1. So, option 1 is the correct answer. Students, next question we are discussing. This question is related to data converters. Data converters. In data converters, the question is related to analog to digital converter. In analog to digital converter, that question is related to dual slope ADC. It is a 3.5 digit digital voltmeter. The reference voltage is 100 millivolts and the first integration time is set to 300 millisecond for some input voltage. Then the disintegration period is 370.2 millisecond. Then the digital voltmeter indicates. It is a standard bit. So many times we solve this type of question. Directly I am giving 123.4 millivolts. Students, question number 39. This is also related to sequential circuit. Sequential circuit question. Sequential circuit. What is the question means? Latch is a sequential circuit that takes all its inputs dash and changes its output accordingly at any time of dash of clock signal. We know in introduction sequence circuit the difference between latch and flip-flop. Flip-flop only controlled by clock signal, but latch is independent of clock signal. Hence, here option 3 is the correct answer. Latch is a sequential circuit, yes, that takes all its inputs continuously, yes, and changes its output accordingly at any time of independent of clock signal. Remember, a flip-flop is controlled by clock signal, but latch is independent of clock signal. Next question. This is related to memories. This is related to memories, and the DRAM, dynamic RAM, stores binary information in internal latches, the form of electric charges on capacitors, programmable or array, programmable and array. We know that there are two types of RAMs, static RAM, dynamic RAM. In dynamic RAM, what happens when the power means dynamic RAM consists capacitors, dynamic RAM consists capacitors, hence it stores information in the form of electric charges on capacitors. That means when capacitor is charging, data will be storing. When it is discharges, data will be lost. We discussed that is in terms of volatile and non-volatile memory, the main difference between SRAM and DRAM. So here the DRAM main important constructional bit is it consists capacitors. It consists capacitor, that only mass capacitor we are using. So it stores binary information in the form of electric charges on capacitors. Hence option 2 is the correct answer. Thank you, students.